All right, let's talk about Kimi K2.5. There's a new open-source AI model on the block, and it's not just trying to keep up with giants like GPT and Claude, it's actually giving them a serious run for their money. And today, we're going to pull back the curtain on the two big secrets that make it all work.
Okay, right off the bat, just look at this chart. Whether you're talking coding, complex agent tasks, or even understanding images, Kimi K2.5, that's the one in blue, is right there at the top, trading blows with the best of the best. Now, for an open source model, that's a huge deal. So you gotta ask, right? How on earth did they do it?
So what is the secret? Well, if you dig into their technical report, the answer isn't just one magic bullet. It's actually two pretty groundbreaking ideas. First, a totally different way of training the AI's brain. And second, a radical new method for how it actually gets work done. Let's start with secret number one, which I like to call the bilingual brain. This is all about how Kimi K2.5 was taught to understand the world. And honestly, it flips some long-held assumptions about AI training completely on their head.
Okay, so check out the contrast here. For a long time, the old way to build an AI that could see and read was to first train a really good text model. Then, kind of late in the process, you try to bolt on the vision part. But Kimi's team did something different. They trained it on text and images together right from day one. You can think of it like a kid learning two languages from birth. They become natively bilingual, instead of learning one language and then trying to add a second one years later.
And here's where things get really wild. You'd probably think that spending all that extra time and energy training on images might make its language skills a little weaker, right? But the exact opposite happened. This joint optimization, as they call it, actually made the model better at tasks that were pure text. The vision training literally reinforced its language skills.
And don't just take my word for it. They've got the data to prove it. Take a look at these numbers from their own report. After they put the model through reinforcement learning using visual tasks, its scores on purely text-based tests like MMLU Pro and GPQIA Diamond actually went up. It's a brilliant little piece of proof that teaching an AI to see can make it a better reader and a sharper thinker. All right, so that covers how Kimi learns. But now let's get into its second secret, which is all about how it works. And this is a revolutionary idea called the agent swarm.
So here's the core idea. Instead of having one single AI try to solve a really complex problem all by itself, which can be super slow, the agent swarm uses a main AI called the orchestrator. Now, this orchestrator acts like a super smart project manager. It takes a huge, messy task, breaks it down into smaller, manageable chunks, and then assigns those chunks to a whole team of specialized AIs that it spins up on the fly.
And this diagram shows you exactly how it works. You've got the orchestrator over on the left, and it gets a big, complicated request. It then instantly creates these specialized subagents, an AI researcher, a fact checker, maybe a web developer, and it gives them all jobs to do at the exact same time. They all work in parallel, report their findings back, and the orchestrator puts it all together for the final answer. It's a huge shift from thinking in a straight line to executing in parallel.
And the range of experts it can create is just incredible. I mean, look at this word cloud from their research. It shows all the different kinds of subagents the orchestrator created during its tests. You see stuff like biography researcher, timeline investigator, cross-reference specialist. So it's not just picking from some preset list of helpers. It is literally building the perfect expert team it needs for the specific job at hand.
So let's put it all together. We've got a bilingual brain and a swarm of agents. What does that actually mean when the rubber meets the road? Well, it means the model gets faster, better, and stronger at solving really tough problems.
How much faster? In some cases, up to 4.5 times faster. That's the biggest speed up they saw with their agent swarm compared to a traditional single-agent approach.
And this graph shows you exactly why. As a task gets more complex, the time it takes a single agent to finish, that's the red line, it just skyrockets. But look at the agent swarm in blue. Its execution time stays almost perfectly flat. Because it can do all the work in parallel, it just avoids the bottleneck that grinds a single agent to a halt. The latency drops dramatically.
But it's not just about speed, it's about quality too. The work actually gets better. On this really tough web browsing test called BrowseComp, the single Kimi agent scored a respectable 60.6%, but with the agent swarm, that score jumped all the way to 78.4%. That's a massive improvement, and it shows that a team of specialists really does get you better results.
So let's zoom out for a second. What's the big takeaway from all this? Why do these two secrets really matter for the future of AI?
It really boils down to 4 key things.
First, Kimi has shown us a new and frankly more effective way to train these multi-talented AIs. Second, it's pioneering a whole new way for AI to work, moving from a single mind to a coordinated team of specialists. The result of all that? An AI that's just faster and more accurate. And maybe the most important part of all, because it's open source, anyone in the world can now take these incredible ideas and build on top of them.
You know, this quote from the research paper just sums it all up perfectly. It's about breaking down complex tasks into smaller pieces that can be solved at the same time by specialized agents. This is a fundamental shift in how we can use AI to solve problems.
And that really leaves us with a pretty mind-blowing thought. For years, we've been trying to build one single AI that can be an expert in everything. But what if the future isn't a single super genius? What if it's an AI that knows how to build the perfect team of geniuses for any problem you throw at it? If that's where we're headed, what currently impossible challenges might suddenly be within our reach?